Welcome back. Now that you've had some practice with implicit differentiation, it's time to take a look at what kinds of questions they ask on the AP exam for Calculus AB. In this video, we'll go through the solution to the 2021 free response question number 5. Before we jump into answering all 4 parts of this question, I'd like to just skim over what the question involves and talk a little bit about things you should pay attention to in terms of how the parts of the questions are related and the way they phrase their questions. First of all, they tell you that y equals f of x. They're telling you that y is a function in terms of x. That's not something we can know for sure unless they tell us. And they gave you a relationship between x and y. And they also gave you a range. They told you that y has to be positive. You need to pay attention to all of those things before you begin doing things. Then part A asks you to show that dy dx equals that expression. It's interesting that they don't just ask you to find dy dx, and there's a good reason for this. Imagine you didn't know how to find dy dx. If you pay attention to the other 3 parts of the question, B, C, and D, they all require that you use dy dx. So they're trying to be nice to you so that in case you mess up on finding the derivative in that first part, that you don't carry your mistake through to the other parts as well. But that means that you have to be very careful about showing your work. When they ask you to show that dy dx equals that expression, that means that what they're checking for is clean, accurate, and organized work that supports the conclusion that that is dy dx. I'll show you how to do that when we work on part A. In part B, they ask you to write the equation of a tangent line to the curve, and they gave you both the x and the y value. We did something just like that in the previous video, so that shouldn't be too challenging. In the next part, they give you a limited domain because x has to be between 0 and pi, and they repeated the limited range, which tells you that y is greater than 0. And they want the coordinates of the point where the tangent line to the curve is horizontal. We also talked about that briefly in the previous one, but we have to apply it to this weird function they gave us. And part D asks you to determine if f has a relative maximum, relative minimum, or neither at the point. Now, if you're watching this video at a time of the year where you just learned how to do implicit differentiation, then this question may be slightly out of your reach. Not too bad. I'll still show you how to do it. But understand that when you practice AP problems, the questions are designed for someone who has studied the entire course already and is now demonstrating the skills they have. So as you watch this video, if the last part seems out of reach for you, just try to follow and understand that you will learn how to find minimums and maximums in the very next chapter you study. So let's actually solve this problem. So the first part asks you to justify why the derivative of y with respect to x is y cosine x over 4y minus sine of x. So we'll start by copying the original equation, 2y squared minus 6 equals y times sine of x. And so we need to pretend that they didn't give us the answer and find dy dx and make sure that it matches what they did actually give us. So taking the derivative of both sides with respect to x, we get 4y to the first times dy dx. Now the derivative of negative 6 is 0. I don't have to write it, but I'll get rid of it in the next line. And then the right side is a product. So to take the derivative of a product, we leave one factor as it is and multiply by the derivative of the second factor, which is cosine of x, and then add, and this time we're going to take the derivative of y with respect to x, which is dy dx, and then multiply by the second factor untouched. Next, we need to find all the terms that have dy dx and group them on the same side of the equation. So we'll bring dy dx times sine of x to the left side. And we'll have 4y minus sine of x. Those two terms come from 4y and sine of x. They both have a dy dx, so we factor out the dy dx and write it on the left side. That covers the two terms that were underlined in green. Then we also have y cosine x that didn't have dy dx, so that remains on the right side. And the final step is to solve for dy dx by dividing by the factor that's next to it. So we get y cosine x, and we divide by 4y minus sine of x. And that matches exactly what they asked us to confirm in the question. If you're the kind of student that tends to do a lot of things in their head and doesn't have very organized work, I urge you to try to work on that and find a way of expressing your work in a way that the graders can read clearly, because you want to get all of the credit and the points assigned to this part of the question. The point is that in this part of the question, the support and the organization is what counts for full credit. Part B is asking us to write the equation for a line tangent to the curve at the point 0 square root of 3. When you hear the words equation of a tangent line, you should be thinking of point slope form, which is y minus y1 equals m times x minus x1. So our goal now is to gather the information we need to fill this equation out. What we need is the point x1, y1, which they gave us, right? x1, y1 is the point 0, radical 3. And the slope we still need to find, but they gave us the equation for the derivative. So you have to recognize that this is a formula for finding slope. So in our case, we need to find dy dx at the point 0 square root of 3. So we plug it in. So we have square root of 3 times cosine of 0 over 4 times the square root of 3 minus the sine of 0. So the cosine of 0 is 1, so we have square root of 3 times 1 over 4 square root of 3 minus, and the sine of 0 is 0. If you need a review of trigonometry, you can refer to a different video to get help with that. So this equals square root of 3 over 4 square root of 3, and that reduces to 1 over 4. So that 1/4 is the slope we were looking for our tangent line. The equation of the tangent line will be y minus the square root of 3 equals, and then the slope, 1/4 times x minus 0, which is the x-coordinate of the point. You can leave the minus 0 there, or you can simplify it if you wish. But this form is very informative because it shows you right there that the point of tangency is 0 square root of 3 and that the slope is 1/4. So I would leave it like that. Part C is asking us to find the coordinates of the point where the line tangent to the curve is horizontal. So we've talked about this before, but the horizontal tangent means the same thing as dy dx being 0. If you think about what any graph looks like, if it has a horizontal tangent line, the slope of that horizontal tangent line is 0. So our task is to set the derivative equal to 0 and figure out where that happens. Now, since dy dx is y cosine of x over 4y minus sine of x, and we were asked to find where this equals 0, a fraction only equals 0 where the numerator equals 0. So y cosine of x equals 0. We were also told in the prompt right here that y has to be greater than 0. So this y can't be 0. So if you multiply y, which is not 0, by cosine of x, and you expect the result to come out 0, that means that cosine of x has to come out 0. Now we have to figure out the cosine of what is 0. And remember that cosine is the x value of the unit circle. So wherever the x values are 0, at those two locations, the cosine of that value will be 0. So we're talking about pi over 2 and 3 pi over 2. But also remember that the limited domain that they gave us in the problem says only between 0 and pi. So we're only interested in that one, and we'll toss that other point out because that's outside of the domain we were given. So that tells us that x has to be pi over 2. I've seen a lot of students get confused here because the unit circle has x values and then this problem has x values. Those are different x values they're talking about. The x coordinate on the unit circle tells you the cosine of the angle, but we're only using the unit circle long enough to figure out what we took the cosine of to get 0. And that value is pi over 2. Now that we know that x is pi over 2, now we have to figure out where that happens on the original curve. So what we're missing is a y value. For that, we're going to need the original equation that relates x and y. So they told us that 2y squared minus 6 equals y sine of x. And we just figured out that x was pi over 2. So if we plug in pi over 2 for x, we get 2y squared minus 6 equals y times sine of pi over 2. The sine of pi over 2 is 1. So on the right side, we just get y. Subtracting the y to the left side, we have 2y squared minus y minus 6 equals 0. Since this equation is quadratic, it is implying that we're going to be finding two y values, possibly. You can use the quadratic formula if you like, but I find that whenever a quadratic expression is factorable, that is probably the easiest way to go. So this factors into 2y plus 3 times y minus 2, and that equals 0. By the zero product property, it means that one of these two factors has to equal 0. So 2y plus 3 could equal 0, which means that y is negative 3 halves. Or it could be that y minus 2 equals 0, in which case y equals 2. But they told us in the question prompt that y has to be greater than 0. And that means that we're going to dismiss that choice because y has to be positive and negative 3 halves is negative. So we have y equals 2. The question was asking to find the coordinates of the point. So they were suggesting that there is only one point where the tangent line to the curve is horizontal. So we found the x value is pi over 2 and the y value is 2. So that's the ordered pair where the tangent line is horizontal. Now, as I mentioned earlier, Part D involves knowing about minimums and maximums, and that is usually taught in the unit after implicit differentiation. So if you're watching this video at a time where you just learned implicit differentiation, don't stress too much about this part. I'll give a quick review just so that you can follow, but trust in your teacher that you will learn this in depth in the next unit. There are two ways to determine if a graph has a minimum or a maximum. The first way is called the first derivative test because it uses the first derivative. So if you think about what a maximum looks like, at this point right here, the graph has a horizontal tangent line, so the slope is 0. But right before you hit that, the graph has to be increasing, which means that the value of the first derivative is positive or greater than 0. And then afterwards, the value of the first derivative should be negative because the graph is decreasing. So as a statement, we say that if f prime changes from positive to negative at x equals, let's say a for some number, then f, the original function, has a maximum at x equals a. And when you have a minimum, the slope of this tangent line is also 0, but the slope before is negative, so f prime is less than 0, and the slope afterwards is positive. So the same statement can be made, but the other way. So if f prime changes from negative to positive at x equals a, then f, the original function, has a minimum at x equals a. That's called the first derivative test because we're looking at the signs of the first derivative. Very often, this is the way you're going to check if a function has a minimum or a maximum. The problem with this method is that it relies on checking the signs of the derivative f prime before and after the x value a. But when we have a curve that depends on x and y, it makes it very difficult to check on either side of the critical point. In those cases, we would try something else called the second derivative test. I'll mention again that if you haven't studied this topic yet, this can get a little confusing because we're going to talk about concavity now. But try to follow along anyway. So suppose you had some maximum. At here at the top, the slope would be 0. But we're not going to analyze the rest of the behavior in the same way we did before. This time, we're going to pay attention to the fact that this curve I drew was concave down the entire time. So two things are happening here at the same time. The value of the first derivative at whatever x value we're talking about is coming out 0 because the tangent line is horizontal. But something else is happening too. Because the function is concave down, that means that the second derivative at a is negative. If you haven't learned that yet, you'll need to trust me for just right now until you learn this in class or watch a different video. And when these two things happen at the same time, where the first derivative equals 0 and the second derivative is negative, that results in f having a maximum. On the other hand, if you had a minimum where the slope equaled 0, now this graph in here is concave up. I didn't write it before, but I'll write it now. This top one was concave down. So if you have a situation where the first derivative comes out exactly 0 and the second derivative comes out positive, because that's what concave up means, that the second derivative is positive, when these two things happen together, that means that f has a minimum. Both of these methods, the first derivative test and the second derivative test, are useful on functions. But when you have a curve that isn't a function and it's given implicitly, then the first derivative test is difficult to apply. It might still be possible, but it is the harder of the two ways. Going back to part D of this AP question, they're asking us to determine whether f has a relative minimum, a relative maximum, or neither at the point found in part C. the point we found in part C was pi over 2 comma 2. It is possible to use the first derivative test to answer this question, but it is the more complicated of the two. So I'm going to show you the second derivative test way. But for that, you have to be able to find the second derivative. They gave you the first derivative, so now we need to find the second derivative of y with respect to x twice, which means we need to find the derivative of the expression for the first derivative. Since it's a quotient, we need to carefully apply the quotient rule. So we start with low, so 4y minus sine of x, times the derivative of the top, and the top is a product, so we have to be extra careful. So we need to pause the quotient rule while we do the product rule to take the derivative of the top. So we can have y by itself and take the derivative of cosine of x, which is negative sine of x, plus, and then the derivative of y is dy dx times the original cosine of x. That's the product rule, which gets us the derivative of the top. But now we have to go back and continue the quotient rule. So we did low, d high, minus, now high, we just get to copy y cosine x again. The derivative of the bottom is just 4 minus cosine of x. That one wasn't too bad. And then the whole thing over the denominator squared. So 4y minus sine of x squared. We could spend the time simplifying this expression, but that's not really efficient because they're just asking us to determine if we have a relative minimum or maximum, and that's going to depend on the sign, SIGN sign, positive or negative value of the second derivative at the point pi over 2 comma 2. So really, all I need to do is plug in pi over 2 comma 2 into this expression and then figure out if we're going to get a positive or negative result. So we have 4 times 2 minus the sine of pi over 2 is 1. And we're going to multiply that by 2 times negative sine of pi over 2, which is negative 1, plus. Now we need to evaluate dy dx. But really, we don't have to spend much time plugging it into this expression because the way we got the point pi over 2 comma 2 was because they asked us when is the tangent line horizontal. So we already know that at this point dy dx is 0. We'll put it 0 there. And the cosine of pi over 2 is 0 as well. Continuing, we have minus y, which is 2, times the cosine of pi over 2, which is 0. So that'll be 0. And the purple part really doesn't matter what it is because we're going to multiply by 0. But still, we'll follow through. 4 minus cosine of pi over 2, which is 0. And the whole thing over 4 times 2 minus the sine of pi over 2 is 1 squared. Several things are interacting with zeros here. So 0 times 0 is 0. We can ignore that part. And 2 times 0 times anything is also 0. So we can ignore that part. So let's see what we have left. We have 8 minus 1, which is 7, times negative 2 over 7 squared, which I'll write for efficiency 7 times 7, because then I can nicely cancel these two. And we're left with negative 2/7. Now what we found is the value of the second derivative of y with respect to x twice at the point pi over 2 comma 2. What's important about this is that it is a negative number. And we already knew that the value of the first derivative at pi over 2 comma 2 was 0. So this meets the conditions for the second derivative test. If the value of the first derivative is 0 and the value of the second derivative is negative, that means that we have a concave down shape with a horizontal tangent line on the top, and so that proves that we have a maximum. In the question, they use the terms relative minimum and relative maximum, and that's because this graph could possibly shoot off like that later in the future and have points that are higher than this one, but relative maximum means that it is, at the very least, the top of its own little neighborhood. So this is a relative maximum. If the solution to part D was overwhelming for you, come back and watch this video again after you finish your course or after you learn this topic, and use this problem to study for the AP exam. And I'm sure that this solution will be much more comfortable at that time. Thanks for watching. I hope you enjoyed this video. See you next time.